Okay, we're live.
Hello, everyone, and welcome to this Just Talking event on Earth observation and climate change. So first, a quick introduction about the Institute and who we are. And it's myself and Javier here representing the Institute for the Internet and Just Society, which is an open platform that connects civic engagement with interdisciplinary research. And we empower young people from all over the world and across cultural backgrounds to find progressive solutions to the most pressing challenges of our digital society on different topics, from fair artificial intelligence to inclusive digital governance and human rights in digital spheres. And Javier, who will moderate this discussion, and also myself, we are co-leads of the cycle on technology and sustainability, where we study the different ways in which emerging technologies can contribute and accelerate the green transition. And for today's Just Talking event, we have around 45 minutes for a discussion with our two guests that we are very lucky to have with us. And there will also be time for a Q&A session at the end. So if you have any questions, please put them in the Q&A section here on Zoom, or you can post them on the live streaming on Facebook. So we will keep our eyes on that as well. Okay, Javier, the floor is yours.
Thank you very much, Josephine. So today we're gonna discuss about the role of satellite technology in the fight against climate change and how Earth observation data can improve environmental monitoring. As you may probably know, we are in the middle of a climate crisis that is having serious impacts on the planet, with dramatic consequences for nature, ecosystems, and also human life. Accurate environmental data is key for scientists to understand, assess, and predict the impact of the climate crisis, and also for policymakers to advance effective strategies to mitigate and adapt to climate change. However, monitoring environmental changes is not an easy task for several reasons, and here is where satellites come into play. Satellites could improve environmental monitoring as they can reveal patterns and track changes that are hard to detect from the ground, providing consistent and reliable data in the form of imagery. There's also a space revolution going on. Today, there are nearly 3,000 satellites in orbit, and the sector is expected to grow rapidly in the coming years, following recent breakthroughs in satellite design and launch operations, and also progress in spatial resolution and artificial intelligence. With all this in mind, we have today two key speakers who will discuss with us all these topics. First, we have Grace Michel. She's a data scientist at What Time, which is a newest environmental tech nonprofit whose mission is to give everyone the power to choose clean energy. Since 2019, Grace has led a project supported by Google.org that aims at modeling and monitoring power plant generation and emissions. The project is now part of Climate Trace, a coalition of organizations in collaboration with former US Vice President Al Gore. And Grace is also a co-lead of Diversity, Equity, and Inclusion for Women Plus in spatial. Second, we have Dr. Rochelle Snyder. She's a research fellow in artificial intelligence for Earth observation at the European Space Agency. And she's working on extracting knowledge from satellite data and using it for public health applications. She's also a visiting scientist at the European Center for Mid-Range Weather Forecast, and also an honorary assistant professor at the London School of Hygiene and Tropical Medicine. Welcome, the two of you, and thank you very much for staying with us in this topic today. So to introduce the topic, as I think many or some people in the audience are not aware on what is going on in the space, I would like to start asking you, Grace, what is the current state of affairs of satellites in general? Why satellites are so important in our life, and more specifically as regard environmental issues?
Yeah, thank you for that introduction, Javier. Really excited to be here. And I would say that the current state of play between public and proprietary organizations, there are many satellites already in orbit that have been collecting data for years. And in terms of environmental data, there's sensors collecting information like land surface temperature, soil moisture, etc., on the country level or maybe at more granular levels as well. And this is happening on a global scale. So each country may have several programs or things in the works. So there might be many other, programs and data out there that I'm not even aware of yet. And I would say that the current state of art in terms of tracking emissions and pollution are OCO2, which is like the orbiting carbon observatory, and then there's also Sentinel 5P. But these sensors are measuring a variety of different emissions, but it's really at the atmospheric, kind of a more granular level. It's pretty difficult to attribute these data to point source emissions, and that's definitely a really exciting kind of innovation within the field that should be coming out in the next couple of years. I know NASA has a program that's currently in development where you can have much higher revisit rates. And that's also something that you have to consider. A lot of these data aren't appropriate for every use, or it might be more appropriate to sort of aggregate this data to a country level.
What's up?
What kind of orbit pattern each of these satellites have. There's a really wide variety, spatial resolution, what type of bands are available. There's just so much out there. So I would say that for point source emissions attribution, which is what we're working on with power plants, we still have a lot more work to do in terms of taking these atmospheric level measurements and attributing that to any one sort of contributor.
Okay, thank you very much, Grace. Really interesting. So there are many uses of satellite data and satellite technology in general, but I would like to point out, going to the field of Earth observation. Some researchers say that the discipline is living a golden age, and I would like to ask you, Rochelle, why? What are the main drivers of this revolution that is happening with Earth observational data? What is the role of artificial intelligence in this field?
Thanks, Javier. First of all, thanks for having me here today. Very happy with your invitation. So we might living in the golden age, but the satellites are quite old in terms of how long they are already there in place. So we have satellites already for many decades orbiting around Earth. The difference now is that I think is the internet and social media, that we are connecting more with known users or known technical people working on this type of data. So the space agencies are engaging more with this whole community and making the data more accessible for them, making platforms more friendly for everyone, just if they don't know how to manage this type of data, just to play with indirect in the website. You don't actually have to download that. So I think that's the main reason why we are now having this awareness about the satellites and how great is the quantity of data that they can provide. And also one of the drivers of this revolution is us people, because thanks to us, thanks to the people that likes to create and share code on the internet, is making this data more available. Because, for example, if you are learning how to use a specific platform or a specific data, you go online and find people that have a specific website, a blog that teaches you step by step how to reach this data set, how to manage the data set, and also provide the online algorithms for that. I think that's the beauty of the revolution. And this also makes possible for people that are already aware of the satellites, but are using just any specific type of satellite. For example, is specializing using the land cover from the satellites, but now wants to engage with air quality data. So it's a different type of satellite, it's a different type of technique a different measuring technique from the satellite. And then you need to learn again how to do it. And then you go again online, and then you find people that is engaged with that and teach you how to do this. So it's a whole community process. And the AI role on that, I would say that for us at ESA, at the PhilLab, I have a lot of other colleagues working with me on that mission in using AI for Earth observation. And for us, AI is the greatest ally to make more value from the Earth observation data. Because as Grace mentioned, we have an amazing quantity of products that the satellites can provide, but sometimes they are not directly suitable for the purpose. For example, if you need to have the human exposure to a specific pollutant, you cannot directly take this from the satellite. You need to do some pre-processing and apply some AI technologies to actually obtain the real exposure of the pollution in the human level. And as in other research fields, we also have complex tasks to solve with AI. And in our department, for example, we are using AI for detecting tropical cyclones, wildfires, using what we call it the near real-time satellite measurements. But this is also able, the AI is also able to use, to correct the measurements from the satellites, because as any kind of equipment, they are precise, but they still have some error on that. So together with AI, we are able to reduce this uncertainty around that error. And in more related with my area, my field at the PhilLab is reconstructing air pollution in areas that we just don't have data from the ground measurements. So for example, we have monitors measuring temperature, measuring pollution data around the world, but some areas or some specific portions of a country, we just don't know anything about it. So the satellites are able to help us with that.
That's super interesting. Before going to the next question, I would like to ask, because I work as a data analyst as well. So you can make some work with satellite data nowadays with a normal computer, or you need like a high computing power to do something? I had that idea in mind. Like, it's true what you say. Like, there's a huge community here, and it's really good because more people can know and get to start doing things. But is it possible to do with a normal computer, or because I guess the size of the images and so on is so big that you need some power here, right?
Well, it depends of your task. For example, if you want to analyze just one day or 1 year of the land coverage, the types of areas that you have for a specific country, you are able to manage this in a normal computer. But if you, for example, want to track pollution for the last 10 years and run a machine learning algorithm on that, definitely a supercomputer.
With a monster.
Yes.
Yeah, I would also want to chip in there that using cloud computing in partnership with just a standard laptop, like I have like a MacBook Pro, takes a lot of the load off of something that your computer might not be able to handle and storing large data sets. So we've been working with Google Cloud Platform, but there's a number of different services where you can really easily kind of remotely connect to a different instance or virtual machine is what they're called. So, and it can be, relatively very cheap or even free, for the first couple of months. But as Rochelle said, definitely totally depends on your task. But I'm pretty impressed by what I can handle on my laptop alone.
And also another important information related with the space agencies, they are also creating platforms where you can actually work in coding inside of this platform, and you don't actually need to download this bunch of data. You just extract the final CSV file or the final information that you're looking at. And we also have the Google Earth Engine platforms, which is aligned with this satellite data that you can actually code inside and just extract the final information from that.
Wow, really good to know, really good to know. Okay, so let's go to more specifically what you're doing in your careers now. So I would like to start with Grace. So I would like to know a bit more about what time and the project you are leading, you are working on. You have worked in the last years. So the idea is monitor emissions from power plants and also other sources in near real time. How do you do it? And also, I would like to ask how all this started.
Yeah,
Who,
yeah.
who was the
So
idea?
yeah, definitely. So I was working as a data analyst at Watt Time, and the Google.org AI Impact Challenge came across our desks, and we all thought, okay, this is something we really want to apply to. So I led the application process, and we submitted 2 applications. One was around curtailment, and then another was for this project, which was to create what we're really trying to do is recreate data that's already available in certain countries, especially wealthier countries. So the US has hourly plant level generation and emissions, and that data is super valuable to Watt Time. It's actually like the input to our core product, which is marginal emissions rates, which is basically describing if you're using energy in a specific place at a specific time, what are the emissions impacts of that? Could you maybe shift flexible energy usage to a different time and use less emissions? So that was kind of what I was working on originally, modeling those marginal emissions rates. And then we sort of pivoted into this project once the application got picked up. And then it kind of just snowballed from there. And really the core of that is because this data is so like useful, like this data is incredibly valuable. So we're really trying to recreate that plant level information, which can then feed into a bunch of other different models, for example, but also for, things like greenhouse gas inventories. We're really trying to align with the UN sustainability goals that are coming up in 2030. And to really make those goals possible, you need some sort of unbiased mechanism to track emissions. And that's what Climate Trace does. It's basically like taking what we're doing with power plants and applying that to a number of different sectors like agriculture and maritime shipping and all of these variety of things, transportation, waste. So you really need good point source estimates of what is happening that's unbiased. So to make that possible, we kind of started with what any machine learning problem needs. You have to first define what the objective is, and you have to build a training set. So to do that, we really relied on the data I mentioned from the US, as well as a number of other countries, to build this historical set of these are all the plants that we have, and that's what we call ground truth data in this project, which is the generation and emissions of power plants. So you're basically matching on time stamps. This is what the power plant was emitting, that's what it was generating, to a satellite sounding. And we really wanted to rely on satellite data because it is available at the global scale. So as you can imagine, the data pipeline is hefty. It's a lot of work to clean this data and to make it usable. We're working with a variety of different satellite collections, trying to get as much coverage as possible. We're also using Google Earth Engine, which Rochelle mentioned is an amazing tool. A lot of comes with a lot of challenges and problems, and all of that creates a very clean labeled data set, which then can be modeled upon. And we're trying to predict whether or not a power plant is on or off first, and then we can later predict what was the actual generation. And generation is a really good predictor for emissions at the plant level. So all of these things kind of take building blocks, and that's really what we started with. We were like, how can we make this problem, which is very complicated, kind of as simple as possible? And we've definitely had a number of really just kind of interesting findings where certain power plants have really clear, strong signals, especially visible imagery, but other power plants don't. We've been trying to group by fuel types and certain technologies, and we're finding out what really works for these specific power plants. And I think the more work we do on it, the more complicated it gets, honestly. But that's kind of where the project started, and that's where it's going now. And we've been working on coal and gas power plants specifically.
Well, really, really amazing. Really, really amazing. So you're dealing mostly with greenhouse gas emissions, but there's also another problem, which is air pollution. And here, Rochelle, I think you can tell us more about this. So you're, well, the World Health Organization estimate that there are over 7 million people, 7 million people dead by air pollution every year. And then you're working with satellite data and the link between satellite data, climate change, and public health. Can you tell us about this link and how satellites can contribute to improve public health? That's the question, and super interesting as well.
Sure. Just an idea why the satellites are actually work on that as well, why we have the monitors, the air quality monitors. But one important information that you raised about that the World Health Organization already showed that a lot of people died because of the pollution. So a lot of environmental epidemiological studies, they rely on weather stations and weather air quality monitors to address the human exposure to a specific pollutant, as I mentioned before. The problem is that these are very expensive equipments, and very often they are not well distributed across a specific location, let's say across a country. So you have a high concentration of monitors in a specific large city, but in the countryside or suburban areas, you don't have information at all. So the idea of the satellites is not to replace this kind of equipment, is just to complement in areas that we just don't have data. So the idea of the satellites, they provide this information to reconstruct in areas that you don't have their quality monitors, but also they don't work alone. They work in collaboration with other types of data. So we also have, for example, what we call the atmospheric modeling systems, where you use the satellite data inside to be able to provide the pollution concentrations in different levels of the atmosphere, but also in different places around the world. And it's the power of this collaborative data collection for that specific task. So in terms of air quality, we have satellites measuring specific pollution such as NO2, but also for pollution such as PM2.5, which is also very dangerous for our health. They don't measure directly. They measure a proxy of that, and then you need to have the other satellite products and other types of data to be able to actually obtain the estimated value on that.
It's really complex. Also, Grace, like you have mainly work with greenhouse gas emission, carbon dioxide, but you also in a post said that your model, what you are doing in what time, could be also used to deal with the kind of pollutants Rochelle already said. How are the progress in that direction, and how can you do so? So you're training your machine learning algorithm to deal with carbon dioxide, but how difficult is to switch to change to other pollutants? You have to change completely the model. Can you rely on some parts of your algorithm, or how
Yeah,
can it
so
be done?
yeah. So we've been working with CO2 specifically, since that's the I guess like highest priority pollutant in terms of power plants. But you can easily, I'll say easily asterisk. Once you have a CO2 estimate, there's definitely a number of emission factors where you can then estimate, okay, if it was this much CO2, it could be that much in terms of SO2 and NOx, which we have data on both of those things within the US. But the issue is that the emissions data is just very sparse. So as Rochelle was saying, it's like, the point is we're trying to have this data available everywhere. And it's really difficult to do that without introducing some bias. So like if we're always training on US power plants, how are we going to generalize that to other countries? And that's a really big question that we're trying to tackle. And we're finding that power plant generation is going to be your strongest predictor of what the emissions would be really for any pollutant. And you can historically look back and say, okay, for this set of power plants, this is this relationship. You don't even necessarily need, machine learning to do that. But I would say that we're finding, there's so many factors at the power plant itself that's going to change what the emissions are. So that could be the type of cooling technologies available at that plant. Some plants, more modern plants, have control technologies. So they're like literally scrubbing these pollutants before they're released into the atmosphere. There's so many different factors, the type of boilers, the efficiency, the age of the plant itself, which I probably already mentioned. So we really need to do more to kind of understand better what different type of plants are out there. And you would think that there's like one, really good source of like, this is the global set of all power plants ever. And we're finding that a lot of these data sets kind of mismatch in terms of which technologies are reported and the age of the plant, and fuel type is also a really big factor as well. And it's pretty common for power plants to get converted to different fuel types, or maybe they get demolished or converted into something else entirely. So kind of keeping track of the fact that these power plants are kind of like living systems that are in flux, and they're also driven by markets, which are inherently random. So there's kind of a lot of different factors that we have to think about before we can just generalize from CO2 to other pollutants. And it's even more complicated by the fact that we don't really have that data available in many countries. So at this point, our approach is like, we're going to do our best to estimate generation, and then we'll add on estimates for CO2 and other pollutants on top of that.
Good luck with it.
Thank you. We'll need all the help we can get.
All right. So, Rosal, I would like to ask you, you recently joined the European Space Agency. So this organization is dealing with a lot of projects. So I'm curious, I would like to ask, in which kind of projects are you involved in? Because you will have I guess you will have the chance to cherry picking a bit the projects you like and see what they are doing. So which kind of projects are you dealing with? Which is your favorite? What you enjoy the most? This kind of question.
It's difficult to tell you which one is the one that I like most, because first of all, we at the PhilLab we are working with a lot of projects involving a variety of outcomes. Let's say the ones that I like most is those that are engaging with public health applications, because is the idea of applying Earth observation data for this specific area of research that needs a lot of help from us on that. But before that, I think it is nice to know that ESA uses its broad selection of assets to support the public health. It's not just our department, but the ESA as a whole. And in terms of projects, we have an exciting pipeline on that. And one of some examples that I can give to you is we have a collaboration with other organizations. And one of the organizations is UNICEF, that we are working in dengue forecast modeling for a Latin American country. And we work with them on that to develop this model. And it's a mix of AI technologies with Earth observation data with a global impact, which makes even more powerful and exciting to work with. But I have also colleagues that are exploring the COVID-19 pandemic, of course. We are trying to link the possibility of the COVID spread with climate and atmospheric variables on that, if there is some influence on that. But we also not work only with satellites that are orbiting around us. We work with remote sensors on the ground, which are the air quality monitors. So ESA has a program of low-cost air quality sensors that we are trying to work in developing these low-cost, trying to find the best assemble of equipment inside of a specific and small monitor, and then we can give this we can spread this low-cost monitor around Europe and develop more the power of these connected environments, connected equipment to link this with the satellite data. And we also engage the schools on that specific project, where we invite them to work with us and to assemble actually these sensors to make all the air quality, the NO2, PM2.5, temperature sensors, put everything together in a specific gadget, let's say. But we don't lead in all the projects. We like also to work in collaboration with the external partners. So we also work in collaboration with industries, the startups, and also universities. So we actually don't need to lead in a specific project, but we are happy to be involved and collaborate.
All right. Now that you mentioned the COVID pandemic, do you think that after this pandemic, people is getting more attention to, paying more attention to air pollution in general? And do you think that has affected your organization?
I think they gave more awareness about the benefits of the satellite applications. And one example of that was the Sentinel-5P, which is an air quality satellite from ESA, which provides us this idea of with the lockdown worldwide, that the air pollution concentrations for specific pollutants dropped dramatically. And this was from the satellites, the opportunity to have this information worldwide and monitoring in the real time of that. So that was the great example of what we can engage in the future with the satellite technologies.
Okay, okay. I think we're having troubles with Grace. Are you there, Grace?
Hi, yes, I'm here. Sorry, my internet.
I couldn't see you. Okay, so I have another question for you. So you have been working on the project of what time, and this has an end, and I guess the end is to get this data available or to publish it. What do you expect following the publication, the release of this data? I read that you're expecting to release this summer. Are you positive about this, or maybe it would be a bit delay, or but yeah, especially
Yeah,
what?
so,
Yeah, you tell me. Yeah. Grace?
yeah, sorry, breaking up a little bit. Can you hear me?
Yeah, I can.
All right. Yeah, so we are planning a release this summer, and this isn't for just power plants emissions data. We're also planning to release across all of the climate trace organizations and sectors represented there. And this is really just the preliminary sort of first launch. We plan to continuously release more granular data over time. So this release is really focused on the UN sustainability goals that I mentioned before. So we're really talking kind of like country level sort of annual data across the different sectors. And this is really our focus because obviously, yeah, sustainable development and climate goals, it's kind of, I would say, surprising and shocking, like how little data there is available kind of on the global scale. And even if there is data available, it's really not the most trustworthy. So really trying to just step up what global inventory kind of data is available. But in terms of reactions, you know, like not every country is going to want this data to be public. They already do have a number of countries that are monitoring emissions, and they have this data, but it's just not available to everyone. So, you know, power plant operators or people within the energy sector, they can access this data, but others can't. So I think there's going to be a wide range of reactions. I think people are going to really want to pick the data apart and really understand, you know, how we got it, because either they'll want to just understand how they can use the data and what the limitations are. I think either they'll be really excited, or people will feel, you know, sense of fear and anxiety. You know, we're being spied on, you know, people are, you know, trying to kind of like poke at us and tell us that we're doing a bad job, you know, track our emissions, or maybe, you know, the data that they're reporting isn't entirely accurate, and maybe that will kind of unearth some sort of, I guess, unsavory thing. So yeah, it's going to be kind of crazy to see, I think, what the reaction will be. We're really just hoping this data will be used for a number of different purposes, really for, climate. And it's all good and well to sort of tinker away and build models and build a data set, but if nobody uses it, that's a failure. So I'm just really excited for, even if it's good or bad reactions, as long as people are aware that it's out there, it's usable, and really trying to express and communicate well sort of the AI responsibility aspect and what are the biases introduced in training and how can people really use this data. Definitely hoping that people won't take it and run with it either. So hoping for something kind of in between, but I expect there will be a wide range of reactions.
Do you think your monitoring data can become a standard in the coming future? So the way you are monitoring emissions from power plants can become better, or completely turn apart the traditional way of monitoring emissions with the sensors, ground-based sensors?
That's an interesting question. I'm not sure if we'll ever be in a place to completely eradicate the ground-based continuous emissions monitoring system, but I think that the future of these satellites coming out over the next couple of years, with enough revisits and with accurate enough sensors, I think that you could really make the case that they don't need these ground-based sensors anymore. But it's also different uses. So there's the use that we're going for, which is we want to track these emissions for certain standards and compliance, but power plant operators need to know kind of very granular, maybe even minute by minute sort of measurements with sensors that are at the plant. And that's really for like operations and maintenance, because that could be a sign if you're having a sensor that's emitting X amount of CO2 and that's kind of unexpected or a wide range, you may need to change something about your operations right away. So it's kind of like, because power plants are so complicated, I think that the continuous emissions monitoring systems that they have on the ground may always be very useful to them. But for us and others who are really interested in, okay, what was the actual emissions polluted at that time, satellites plus a combination of AI might be, perfectly fine for that. But I think there is always going to be a need for a number of different ways of tracking.
Okay, thank you very much. Rochelle, I would like to continue with you. While I was preparing this webinar, I read about this paper you present at the end of last year, where you presented with other researchers an air pollution map across the UK, and proposed that the next step of this research could be linking this map, this air pollution map, with health records. How is this? How can you do this? How difficult, how tricky can this be? But in any case, I think it's really interesting, like what you were proposing here. Also, the map is amazing. So can you tell us a bit more about this project, this paper, and the next step in the coming future?
Yeah, so that's the mission of this paper, is linking these benefits from satellites and AI for public health applications. So this paper actually is a great example of how can we work together in a common goal, linking AI, Earth observation, and public health. So this was a need from this community, which needed to have this high level in high spatial temporal resolution of PM 2.5 concentrations around the location, and they didn't have enough monitors on that. So that's the reason why we approached this framework to solve the problem. But this paper is also a great exercise in demonstrating how the European Union's Earth observation program, which is called the Copernicus, can support societal challenges, because we not only use the air quality satellites there, we use a lot of other services that are provided from it. So we use the elevation, we use the land cover, we use the temperature, wind, and all this information that is based on satellites. So in this case, we have to use the machine learning algorithms on that to give the strength of the performance of our models. And just to have an idea, that's a very good question. Like, how are you going to link this map that is varying the pollution data every day? How are you going to link it with the health outcomes? So basically, we created this. You have the location. In this case, in this paper, is England, Wales, and Scotland. So we create a matrix on the top of the area with a lot of grid cells with the size of 1 kilometer by 1 kilometer. So this is around 234,429 pixels, grid cells with PM2.5 concentrations. And this varies for 11 years and for every day during 11 years from 2008 to 2018. And in this case, so now all the health records can be linked with this data set. So it doesn't matter anymore if you are in London, if you are in the countryside, or if you are in a remote area of Scotland, you're gonna have exposure, a PM2.5 estimation in that specific location. So in the health outcome, in the health database, they have different aggregations. So they provide to the health community the health data varying, for example, at individual level, which is, for example, you have a specific health record at postcode level. But we also have other types like mortality varying by day at the census level. So in this paper, we provided a structure that doesn't matter which is the aggregation of your health records, you are able to adjust this information to be able to link that with our maps.
I will make the same question to Grace. Do you think your methodology can become a standard, like the way you are measuring air pollution? You think this can be replicated in other countries? And do you think at one point, eventually the ground-based sensor won't be necessary to measure air pollution?
Yeah, I mean, I think we can definitely continue our methodology, and it has been applied to different sectors, and I think there will always be a use for that. But yeah, I definitely want to say, I don't know if you can just completely kind of replace, the technology that's out there. I think that we need to keep building on it and probably maintain as many systems as possible, as well as adding on AI, and probably maintaining that for several years before you can really rule out, okay, what's the best kind of methodology? What's the best mechanism to continue? I mean, in terms of, costs and what's sort of sustainable for a country or for an organization to keep up with, it may end up being that the combination of AI, plus satellites is the best bet.
Okay, so thank you very much for this conversation. And I would like to finish with 2 questions. So I have I see you double, Rochelle, for some reason.
Okay. Yeah, my laptop just dropped it. Sorry about that. The battery.
So my question, I had the impression that all this satellite thing is mostly for nerdy people, let's say. I mean, no, but not nerdy, but I mean, I study law. I come from social science background, and I can tell you that none of my friends are aware of what is going on in the space. None of them are aware of satellites. I think they still think about the Cold War and the first satellites and these kind of things, right? So I think given the growing importance of satellites and what is going on and what you can do with their observational data, I think it would be nice if people would know more and would be more aware of these issues. So I will go a bit personal. So I would like to ask you why did you at the first time get interested in satellites and Earth observation? My second question is, what do you like the most when you deal with satellites and this kind of data? Who goes first?
All right. Yeah, I guess I'll jump in there. Yeah, so my first experience in working with sensors, I was in engineering undergrad. I was working with a project team that made water filtration systems in South America. So the sensors that we were building were very, very different from what would go on a satellite. But I think it gave me the understanding that any physical system, the more sensors you have, and the sensors that are actually calibrated that work, kind of the better maintenance you can have on that system. So Earth is an extremely complicated, enormous system, and having better sensors, better satellites will enable better maintenance of the planet of Earth. And I think that's what's really exciting about it, is just sort of the wealth of information that's available and what you can really do with that information. But it is tough to work with, and I think that's a huge barrier in people's awareness and understanding, even just picking out, which satellite data do I want to work with? It's like Landsat 8 has, 3 different tiers and all different levels of processing. And it's like top of atmosphere or like X, Y, and Z. So it's like, yeah, for most people, it's going to be really overwhelming. And it was for me, for sure. But I think just knowing that all of these sensors are out here to help enable us to make an action, to make a choice that can really impact people's lives. I think that's really powerful. And for the second question, what do I like the most? I really like looking at the visible imagery. I think that's really fun, especially for power plants. It's just really cool to see the different resolution. But then there's also just kind of random things that you see in these images. Like one of my team members found a rainbow, over a power plant, which was really fun. And we're working with Airbus imagery now, which is very high resolution. And one of my coworkers found the large chip that was blocking the Suez Canal. It's kind of like just like fun. You can really see the whole Earth looking at this data. And other things, especially in like the non-visible kind of wavelengths, like thermal imagery, for example, you can like overlay that with physical markers. So even at kind of, I would say like more granular spatial resolution, we were working with Landsat, which is resolution, you could see cool water with hot water coming out of water outlet. Like you could see that water dispersion, which was really cool. I would say that's my favorite thing, is just looking at it.
Nice. And for you, Rochelle?
Well, difficult. I can say that the first time that I saw a satellite image was back in 2010. Was a false color image, meaning that was a combination of areas that we cannot see with our own eyes. We just detect a specific range of, let's say, and the satellites are powerful to also detect areas that we don't see it and extract information from that and bring it to us in a way that we can see it. So this false color is that the example, is the combination of these different areas. And in that case was, for example, to be able to see a water spring under the trees, because looking up, you just see the trees and you don't see what is under that, but might have like a water spring or a lake. And when I first realized that, looking at this image and say, okay, the colors look a little bit weird. You don't actually see the trees as a green, you see the trees as a red, because was this false color of the land. But you saw clearly that there was this water spring, which was high humidity. That's the reason why I spot this location. I realized that this is awesome. This is super cool. And I decided to just go for it and learn more about it. And then I realized, okay, this is from satellite. These are different areas, the bands that the satellite can see. and there are other sensors, and there are other satellites, and they are in different distance from Earth because they need to measure different things at a different time. And then I said, okay, I need to understand every single thing related with that. And then that's the reason why I'm still here and exploring this road of the satellites at ESA. And you asked also about the what was the other question?
What do you like the most when dealing with satellites?
So they are brilliant instruments made by scientists. And today we are just touching the Earth observation satellites. So it's I would say that this is what I like most, is dealing with Earth observation satellites. But we didn't talk today about the other ones, because there are more. So we have the telecommunication, the telecommunication satellites, we have the navigation satellites, and we have the space exploration ones.
Oh yeah.
So this is just outside the Earth observation ones, which are still providing us data and providing us information and giving us the opportunity to be here today, because the telecommunication satellites are the ones that enable us to have this chat online, because they are the ones that give us the technology to do that.
Wow. When do you think it could be possible to take a flight to the international station? Do you think there will be a time where there is a kind of Ryanair where you pay 20 euros and you go to space?
I will be the first one to buy the tickets. Well, this is not, I hope this is something, we have the astronauts that have the opportunity nowadays to make this happen. And they are going more often now, and they are reusing the rockets for that. So this is the great that the space agencies are advancing on that. So hopefully, I would say soon, to not give a specific number, we will be able to be tourists in the International Space Station.
Wow. So thank you very much. I think we have a time for Q&As, some 2 or 3 questions. So some people write on the chat. So there's a question for Grace. Ingrid is asking, why are some power plants imagery clear and strong, while there are others where the data is unclear?
Yeah, so it's all based on the cooling technology at the power plants. So power plants get really, really hot and they produce a lot of steam, which then spins a turbine, depending on the power plant system. And to regulate the heat and steam within the plant, they have different types of cooling technologies, some of which produce a very large sort of like visible plume, and others don't. They just have a different mechanism. They may dump water into like a nearby pond and sort of recirculate water throughout the cooling pond, which is actually obviously really bad for the pond ecosystem. So that's kind of outdated now, but there's a variety of different technologies at the power plant, and it's really down to whether or not there's a clear plume that sort of correlates with generation. So you would expect for some of these power plants, high generation means, you know, big plume coming out of it, but for some plants, it means just the opposite. So we actually do what we call hand labeling studies, where we look through images of these power plants and as a human try to say, do we think the power plant is on or off? If a human is not able to do that, we can't really train a machine learning model to be able to do that either. But there's also a wealth of information outside of the visible band. So that could be something that a stronger predictor has stronger signal at, or not as, I would say, like, you know, it's not something we understand as well as what we can see visibly.
Okay. I hope this answered the question. There's another one addressed to both of you, asking about the possibilities that will open up with this open data. So you said that now this is possible to retrieve data, satellite data from many sources. Do you think this will give more possibilities to people and industries to use this data and to create a brand new market or new businesses in general? And also, what do you think is the future for open data, also as regard to satellite data?
Well, I can start on that. So ESA works a lot with industry on that, in creating value from the satellite data, and engaging with new services and new products from that. So definitely this is making the data available, and making more information from satellites will bring more value for this industrial part, not only research. So that's the mission from the ESA side, is making this not only research but also the industry work on that. And making the data open it's the most valuable an opportunity to actually from that increase more the opportunity to use for areas that we are actually even exploring now. For example, the public health applications is an example that we don't explore, is not an area that is still growing, but is not something that is already there for many years. So with our opportunity to link this data with health applications, give more opportunity to the space agencies, engage on that and develop new products from satellites based on the need from this side.
All right. There's a last question I would like to ask. I think it's for Grace. How do you think all this satellite data and what you're doing specifically in what time can affect the design of emission trading scheme like the one that is in place in the US, I think also in the European Union, also in California, and I don't know in other states in the United States. But how do you think this can affect the designing of these schemes?
Yeah, I think it's all somewhat connected and circular. And I guess going back to the previous question, having this open data and having these platforms that make it easier to query multiple types of data is so powerful and something that's happening now. So we work with Landsat 8 and Sentinel-2, and we'll continue to do so. And I think that whether or not it's publicly available depends on the organization providing it. So you have these proprietary satellite organizations that have very sort of cheap, many satellites, many sensors. They burn out rather quickly, but they can get really high revisit rates, really good resolution. So I think that starting with the open source public data helps you figure out, what do we actually need for this problem? You know, applying this to power plants is a very specific use case, and working with the public imagery has enabled us to figure out, okay, what kind of resolution do we actually need? What kind of revisit rates? And then we can then ask, you know, proprietary satellite data provider, these are the specs that we're looking for. And we can also use that information to help influence what we hope to have as later publicly available. Like NASA, for example, has asked us, what kind of specs do you need for this problem? So I think that if you can carry your problem, you can carry your impact and your use case, and you can inform later launches and operations, that can then become publicly available and something that people really want to throw resources on because they know that it's useful. And I think it's like with a lot of this satellite data, with all of these sensors, I think there is a sense for some people providing that data of who's really using it, is it super useful, like what is actually needed. And I think that the more communication and sort of driving these projects forward, the more attention and resources you can put on it. So I think it's all sort of connected, and I think these things change over time. And as long as you're putting it out there, hey, this is something we're working on, and especially, you know, something like pollutants, you know, emissions, that's something that everybody, you know, wants to put more resources towards, that can help influence. So I would say the public is like absolutely critical in what every project should start with, and then you should work your way up towards there, because there's so many different sources available, and really these proprietary companies, they will take as much money as you will give them. So you really want to have a sense of like, what am I actually shopping for before you go into this very extensive market. And then I guess the other question was, How can we keep the data open? Might not be flattering. Yeah, that's a really complicated question that I unfortunately don't have the best answer to. I think it's all going to boil down to, you know, who's answering to whom and what the expectations are. And if there is a major fallout, I think, you know, particularly people who are living, you know, right next to these heavy emitting power plants are going to be the people who are in the best position to drive some sort of change because they're getting most of the health impacts. And I think kind of on the larger scale of like, you know, an energy market and a government on the country level, you know, there's going to be change, but it's likely to be a lot slower, you know, than if it's like a citizen driven sort of like, we want change now. So I can't tell you, yeah, what the best answer is. And there are sort of like malicious users of this data as well. So we're trying to strike a balance of, yes, we will make this data available, but hopefully we can sort of vet what people are using it for. And hopefully it goes into the right hands. But yeah, we're definitely figuring that out as we go. So if anybody has any thoughts on that, yeah, let us know.
All right. So I think we come to the end. Thank you very, very much for this conversation. It was super nice. It confirms also my impression that this sector and dealing with satellites is wonderful. And I may contact you. So if you can guide me at the beginning steps to do some things, maybe I can find some ruins in the jungle using satellites, whatever. but yeah, it's super, super nice, the conversation. Thank you very much. And yeah, I think that's the end. Have a nice Easter if you have in where you are, and stay safe.
Thank you for having us here today.
Bye bye. Bye bye.